The broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome. My name is David Shepard. I'm the Director of Sustainable Development for the Portland Cement Association, and we welcome you to the EPD Tool User Webinar. This program is made possible by ongoing work by the World Business Council for Sustainable Development's Cement Sustainability Initiative, who created an EPD calculation tool to assist members in changing to an evolving marketplace here. Today's program will be conducted by three of us. The predominant speaker will be Amanda Pike. Next slide, please, Amanda. Will be conducted by Amanda Pike, and for your information, this presentation will be recorded for future access. You're welcome to share this with your colleagues, or if you need a refresher, to come back and take a look at the notes that are provided. As we go through the presentation in the webinar format, it is difficult to handle much of the background noise, so consequently, we will be handling questions through the question drop-down box, which is located in the lower part of your GoToMeeting toolbar. As questions come in, I'll pick them up and address them to Amanda or Arnaud, our other speaker, as appropriate. We will also capture these questions and put them in a Q&A document, which will be handled and distributed to folks that are on the call, as well as posted on the website with the recording. Next slide, please. As I mentioned, the tool is been developed by the World Business Council for Sustainable Development's Cement Sustainability Initiative. These the members of the WBCSD are cement producers from around the globe. PCA members funded a revision or modification to this tool back in 2015, and that work has now been complete, and we are putting this tool into the marketplace. With that, next slide, please. The three folks that are bringing this to you today is, first is Amanda Pike. She's the Director of U.S. Operations with Qantas International. They were also the consultant that developed the environmental product declarations for U.S. cement EPDs for Portland cement, blended cements, and masonry cements in 2015. Also on the call is Arnaud Doriot. He's the managing director for the Swiss office or the Qantas office in Switzerland, and he is the person that actually oversaw the development of the tool and all the modifications that have been implemented in the last year. And again, I'm David Shepard. I'm the Director of Sustainable Development for PCA. And with that, I'm going to turn this over to Amanda to take us through the tool. I'll be monitoring for questions, so as we go along, bring them up, and if it's appropriate, we'll interject them into the presentation as we go. Thank you.
Hey, thanks, Dave, and thanks to everybody for joining the webinar today. Essentially, we'll have four parts to our discussion today. I'm going to start with a few words on LCA and EPDs to be sure we're all kind of singing from the same song sheet. We'll then go to the tool for the demo, and I'll just share some tips as a user of the tool, including how to check your work. We'll also talk about some different ways in which the outputs of the tool can be used, and exactly what the process is for developing a product-specific EPD if you're interested to do so. And in the last half hour or more, we're going to leave that open for a Q&A. But there's a lot of content here, so we're going to pause just before and after the tool demonstration to take some questions about first the LCA EPDs in general, but then also the EPD tool functionality and things that we presented during the demo. So let's go ahead and dive right in here. We're going to start with a brief primer on EPDs and LCA. So the big question to start with, what is an environmental product declaration or EPD? So simply put, really, it's a standardized fact sheet about the environmental performance of a product. And I say standardized because it's generally defined by ISO. There's a specific ISO norm, 14025, that describes what an EPD is. And then further by what we call product category rules, or PCRs. I'm not going to go into detail of PCRs right now, but I will suffice it to say that a PCR is essentially a checklist that describes the information that must be included in an EPD for a specific product category or type of product, like cement or concrete. It also describes many of the aspects of how the environmental impacts need to be computed and reported. So there's some technical requirements as well as kind of a general list of information that needs to be included in the EPD. All EPDs will include a minimum set of information that's defined by the PCR. So you're always going to see on an EPD descriptions of the product and the process for creating that product. Generally, you're going to see any applicable specifications or standards. So, for instance, in the cement PCR that the industry average EPDs followed, it refers to ASTM C209 and C150, among others. And it also, the PCRs also define which environmental metrics need to be reported. So do we need to be talking about greenhouse gas emissions, ozone depletion, waste metrics, etc. Okay. And the EPDs are really used for, I guess, two main purposes. One is to demonstrate transparency by a product provider, but also to communicate on sustainability aspects related to your product. And doing these two things really helps to build credibility for your business with your customers and other stakeholders. And it provides an understanding of the environmental performance of your product. So it gives you kind of speaking points that you can use, but also gives those kind of speaking points or pieces of information to others who are interested in environmental performance metrics or information. But this information can really open the door with a variety of stakeholders. So it's really useful to have, especially in this day and age. A fairly new use of EPDs is in meeting the requirements of voluntary green building programs. I think probably the most maybe well-recognized one or often spoken about is USGBC's LEED v4, which offers points for specifying products that have EPDs. And there's a number of different points that are possible depending on whether you're using a product-specific EPD, an industry average, or whether it's been verified versus simply a self-declaration. And I'll get into kind of what a self-declaration is in a little while. The IGCC, the International Green Construction Code, also references EPDs as just one option to, I guess, in the material and resource compliance pathways. And also the Architecture 2030 Challenge is also recognizing and encouraging EPDs. So there are a lot of programs out there in the green building space that are now recognizing and promoting the use of EPDs. One last point to make on this slide, there are some folks out there who would say that you can use EPDs to compare products directly. That's not entirely true. EPDs can enable comparison between products, but they do not themselves compare products. And this is stated directly in ISO 14025. So it's not something that I'm just saying, but it is there's some scientific basis to it. You can possibly use the information in an EPD to compare products through an LCA, but you shouldn't necessarily compare the environmental impact or performance metrics directly from the EPD, and there's two reasons for this. First, the basis isn't right. So typically EPDs are describing an amount of a product, not what the product provides in terms of its function. So for instance, you wouldn't want to compare a ton of cement to a ton of timber, which is how the results of those kind of EPDs are often provided on this kind of mass basis. You would want to compare it on the basis of, the amount of cement or timber needed to fulfill a specific function. The other reason why EPDs should not be used directly to compare between products is because the environmental metric results might not be comparable. So the PCRs describe how these metrics need to be calculated, but they are somewhat flexible still. You can use, to some extent, a different scope when you're calculating these metrics. There are requirements for data quality, but data sources can be different. And sometimes there is different calculation methodology, especially if the EPDs are following, say, different PCRs. So I don't want to go too much further into that, but definitely let me know if you have questions. And maybe to better understand some of this, I'll talk next a little bit about what LCA is. So oftentimes we resort to using product attributes like recycled content or bio-based or even reusability as an indicator of environmental performance. But these characteristics really tell us nothing about the impact, the physical processes that occur because a product is produced or a service is provided. So this is where LCA can help us. Life cycle assessment is really just a scientific study to measure the impact that a product, a process, or a service has on the environment. It can be used to understand the environmental trade-offs of things like concrete foundations versus ICS, or to model an entire building system and understand the implications of different design decisions. So like EPDs, LCA defines, or excuse me, ISO defines a general approach to LCA, as well as the criteria for using LCA to make comparative claims between products. ISO 1405, which is the EPD norm I referred to on the last slide, it in fact refers to ISO 1440, which is the ISO norm for describing an LCA. And ISO 1405, the EPD norm, uses ISO 14040 for describing how to conduct an LCA for an EPD. So these are all kind of intertwined. But what makes LCA so powerful is that it's comprehensive. So not only is it considering the activities occurring at a production site, it considers all the activities along the value chain of a given product. So for instance, an LCA on ready-mix concrete production, or ready-mix concrete, it considers not only the impacts of, say, producing the diesel to run the truck, but also the combustion of that diesel by the truck, and everything else that goes along the value chain in terms of producing that diesel, using it, and then if there's anything that needs to be managed at the, producing the concrete, using it, and then managing it at the end of its life. LCA also considers multiple metrics, so we're not talking just about carbon or just about water. There are literally dozens of other metrics that can be included, including things like acidification or eutrophication, human health impacts. And this, looking at multiple indicators, what it does is ensure that we're not shifting environmental burdens between impact categories. So for instance, maybe we are reducing our carbon footprint by taking, improving a technology in some way, but maybe it's increasing our smog generation or water use along the value chain somewhere. So we want to make sure we're looking at multiple metrics, not just one. So how is LCA useful to an EPD? I think maybe this is a bit obvious perhaps at this point, or it's becoming clear. The principal piece of information in an EPD is the environmental metric, and these are provided by the LCA. And if you're familiar with an LCA or with LCA, you know that there are many aspects to how the study is performed. You have to consider and define the scope, the data quality, impact calculation methodology, and many other things. And these, again, are prescribed by the PCR so that all the EPDs developed under that PCR are fairly consistent. But as I mentioned earlier, there is still room for differences. For instance, data sources are not usually specified by the PCR, just the data quality, and there could be some important differences between the sources that you're using. So I'll give you just one example. In LCA, one of the most commonly used databases is EcoInvent, and EcoInvent recently underwent a major update, and the new version v3 includes comprehensive data on water use. The prior version, version 2, which is still being used fairly commonly among LCA practitioners, if you use version 2, it will very likely produce different results for water use and consumption metrics because the data is just not the same as in version 3. So you need to make sure that so there are these opportunities for differences to be had in EPDs that are still developed under the same PCR. The other reason why these differences occur is because PCRs aren't always sufficiently explicit. So for instance, take the ASTM PCR for cement. The water metric there is simply net fresh water with no definition. And so in doing the industry average EPDs, we had to make an interpretation. And this is done, fairly commonly, especially when PCRs are new. But we interpret it as water withdrawal instead of water consumption, if you're familiar with those terms. And so this kind of process is fairly typical, and over time, individual PCRs improve as these kind of bugs are worked out through the use of them. And in this case, we have talked with ASTM, and they're cataloging the issue to be addressed when the PCR is next updated. But again, all this to say that EPDs use LCA, but again, we shouldn't necessarily be using EPDs to compare products directly. Okay, so I'm going to pause right there before we go into the demo of the tool and just see if there are any questions about the content that I just presented before we move on. And we can, when we open the floor up for Q&A at the end, we can go back to this information and we'll take questions on everything we've presented. But I wanted to stop here and see if there are any questions related to this specific information.
At this point, I do not have any questions that have come in via the question dialog box.
Okay.
So why don't you jump into this and we'll move forward.
Sounds great. Okay, so let's go over a few pieces of information before we actually open up the tool, but I am going to move over to the tool at a certain point and navigate through it and show you how it works and some tips and tricks when you're using it. So the purpose of the tool really is to help PCA members and others calculate the environmental metrics data that's required by the reference cement and concrete PCRs in the U.S. So we're referring to the ASTM PCR for various cements and the NRMCA PCR for concrete. And so this tool has actually been pre-verified to abide by these PCRs, which effectively streamline your calculation of the environmental metrics and reduces the effort that you need to put forth when you are going through the verification process. And I'll talk more about verification after the demo, but essentially the tool will streamline the LCA process that you would need to go through for your EPD. The tool is a standalone web tool. There's no download required. There's nothing kind of in the background to be putting on your computer. It's all internet-based, but of course you do need internet access to get to it. There's no cost for PCA or CSI members or their affiliates to access and use the tool, but there is a user agreement and a confidentiality agreement that must be signed in order for your company's account to be created. Once that done. A user request form also needs to be completed. I guess that can be done simultaneously. And so if you're interested to do that, go ahead and contact Dave. His email address is here on the screen, and he can get you started with this.
Amanda, I'm going to interrupt and just mention also that through the WBCSD, there is a licensing agreement, fee structured for non-CSI or PCA members. And in fact, there are several folks on the call today who are part of that. In the Oregon Concrete Promotion Group is working with the state of Oregon to provide access to the tool for the ready mix producers in that state. So if there are folks that don't fall under the free access as described on the bullet point above on the screen, please contact me and we can connect you up with our node to investigate that as an option for you. Thanks.
Great point, Dave. Thanks. Okay, so the next point is on support. If you need help, there are resources for you to help you use this tool. And there are multiple resources. So your first stop, I would recommend, should be the user manual, and that's available directly in the tool. I'll show you where that is in a minute. Quantis also has kind of a support contract with PCA, and so there's some limited support available there. For that support, go directly to Dave, and he'll be able to funnel things to us. Otherwise, you can come directly to Quantis, and we can talk kind of on the side if you'd like to do that as well. So lots of ways you can get help. You're not alone in using the tool. A few key features, just let me run through some of them before we open up the tool. From a functionality standpoint, the tool works like many other web tools you may have used in the past. You log in, you enter or upload your data, and you can view your results and export them as well. And then you have the ability to save EPDs right into your own user account. There's a few ways to input data. I'll explain that when we go into the tool. And the reference documentation, including that user manual that I mentioned, can be downloaded directly from the tool. There's a few different items that will be probably really useful and helpful for you as you're working through the tool. So let's go ahead and move forward. I think we can, Dave, unless you see any questions right now, I think I'll go over to the tool and open that up.
Actually, I have one here, and the question is, can I define what affiliated member is? So in the context of this tool use, any sister company of either PCA or CSI members would be an affiliated member. So if you're vertically integrated and you have, say, ready mix operations with, that are owned by a parent cement company that's a PCA member, you have access to the tool. Similarly with CSI membership. So if you've got any question about that, you're certainly welcome to shoot me an email or whatever. All right, I'll let you get back to it.
Sounds good. All right, so let me just drag this over. So as I mentioned, the tool is completely web-based. So you quite literally open up your browser, and you will have a link that is sent to you once you have all of the necessary paperwork in and completed. And so once you enter the link, and this is not the link that you'll be using, so that won't work for you. You will be directed to this login page, and so you'll have for each person. Let me back up. For each company, you can have as many users as you need, as you want. And you'll define that through the sign-up process. And each user has his or her own private account. So other users cannot see what you're developing in your own user account. You can share EPDs. I'll talk about that in a minute. And each user can save an unlimited number of EPDs. So let's log in, and I'll show you more of the tool. Okay, So when you log in, you're going to be taken to this page. All right, and so this is the access page for both the international and the U.S. version. So up top, you'll see a button to click international or U.S., and you want to make sure you're on the U.S. version. It'll actually be white. That's how you know you're on the U.S. version. This button down here will say U.S. version as well. So before I go further, let me just point out two things on this page. At the top, you can change your password here. You can see a little bit more about the tool if you want to click on that and read through that information. And then you can also log out. These buttons, this whole top menu actually, or top, the header up here stays the same throughout the tool. So you'll have access to all of these things, whichever page you're on. There's some more information here, as you can see. And then at the bottom here, this is where you're going to find those reference documents that I mentioned. So there's the offline user manual, the LCA core model and database report, the project database, which provides the data that's in the background, calculations of the tool, and then the verification report. I mentioned the tool is pre-verified, and so here's the report asserting that. So let's go into the tool. I click US version, and then I just click the button down here. It says US version. Okay. So when you first start, this will be blank here, but I've created some EPDs just to kind of get us going here. So what the tool is going to do is calculate the LCA results for a clinker product, a cement product, or a concrete product for you, or multiple products, I should say, because you can create as many EPDs, and I'm calling each of the rows here an EPD as you want. When you log in, this is essentially a library of all your saved EPDs, whether they're clinker, cement, or concrete, and then I'll tell you right here under the EPD type. What you'll do is click once on any of these to highlight it, and it'll provide a description that you've entered down below, so you can see exactly what the product is. And then you'll see all these icons to the right that allow you to do different things. There's an edit or update that'll open it, so you can change information, duplicate buttons. You can export the background report, which is the inputs as well as the results. And you can also export a self-declaration, which again I'll get into in a little bit. So to start a new EPD, there's a few different ways to do it. You can enter directly into the tool, enter data directly into the tool, which I'll show you in a minute, or you can upload a completed import spreadsheet. So let me show you that. And to do that, what you would do is navigate over here to the import-export area, and you would export this EPD template. It's a spreadsheet. So you just click on this, and it'll ask you which one you would like. You select one, and then it'll tell you that it's ready for download, and you can save it wherever you'd like to save it. And then when you have completed that, you would come back here, you'd click import, and you would just select that file, and it would create an EPD in this list, and you can open it up. So let me show you quickly what the template looks like. I'm going to walk you through. I'm going to use the clinker version as an example here. So this is the template that you'll see, and on the so there's an introductory page which has a lot of basic information, including some instructions. So that's probably good to go through once quickly. And then each of the pages, each of the worksheets, I should say, down here is a different page in the tool. And I know I haven't shown you the pages yet, but just go with that for now. And so you can navigate through each of these worksheets and enter data. The tool or the spreadsheet is not locked, so you'll need to be careful to not add or delete rows or columns, and do not change the terminology or the units. And if there's a cell that doesn't apply to you, say you don't use bauxite in your production process, then you would just skip it. You can leave it blank, or you can enter a 0. Either way is fine.
Amanda, I'm going to interrupt you here. Can you scroll back up to the area that had the NERC regions?
Yeah. Well.
So I saw it just a moment ago. It actually had NERC about 8 lines down. Basically, the question has come in, and I don't know if it's appropriate here or now, but one of the questions was, does this tool work for Canadian producers that supply U.S. cements? Or in some cases, we had another question that was right up the same alley, which is, how would you input Canadian clinker for U.S. Grinding facilities? So I assume in both cases you're dealing with a energy grid profile that's coming out of Canada someplace.
Yeah, so in that case, and that's a point I was going to come back to, but I'll definitely hit on it right now. So what you can do is to override the electricity information in the tool and enter the percentage of each energy source that's in your grid. So I can show you that in the tool, but maybe just for now, know that you can override that that selection of the region and enter what your grid looks like.
Do NERC regions extend into Canada?
Ooh. Arno, can you confirm that?
Hi everyone. Regions do not extend to Canada, and the appropriate way to deal with custom mixes, so not matching with any US NERC region, is exactly the way you showed it.
Okay. So modifying or sourcing your energy grid profile would enable you to enter your data as we see on the screen.
That's right.
All right.
Okay. Let's go back to the tool. So let's look at how we would create an EPD with the without the import template. So for each product, clinker, cement, or concrete, you have 3 options. So you've got clinker, cement, concrete here under new EPD, and each one will say either new empty, new default, or new product from self-declaration. If you select the new empty version, it's going to have no data at all. So it'll be just like the spreadsheet that you're downloading if you're going to use a spreadsheet template. If you select the default clinker, cement, or concrete, what you're going to get is a pre-populated EPD, and each of these would be the pre-populated U.S. average clinker, the U.S. average Portland cement, and the U.S. average ready-mix concrete. And if you wanted to enter data from a self-declaration, which is essentially just I'll suffice it to say right now, it's the results of an EPD, the LCA results from an EPD. Self-declaration means that it's been unverified, but you could use verified or unverified data, really. And you would just enter the results from an EPD that you have. So maybe this is useful for if you're a cement or a concrete producer, and you have LCA results from someone that you're buying clinker from or someone that you're buying cement from. You can enter just those LCA results here. So as I said, new clinker from, I guess we wouldn't want the clinker. New cement from self-declaration. You would literally just enter the results in this table for each of the metrics. So if you have an EPD and all you have are the results from that EPD, and you know it's applicable for your product, you can enter that here. Okay, so why don't we go through the process of creating a new clinker EPD. So let's see here. So I'm going to say I want a new empty clinker. And this process will be the same for cement or concrete. I'm just using clinker as an example here. Inputs are all organized in the same way as for the clinker. And a lot of them are actually the same. So the first thing that you'll see is this description page pop up. And there are a variety of pieces of information that the tool will ask you for. The starred items are required, so you won't be able to move on until you enter that information. So I'll just enter something here so we can get started. Your production site might be the name of your site or an identifier. Your site production capacity, this is only going to be used if you are including infrastructure, which infrastructure is in fact a non-required, voluntary inclusion according to the NRMCA and ASTM PCRs. So you have the option to include it here. If you include it, what's going to happen is that the tool will automatically include an impact related to infrastructure based on your production capacity. So it's kind of inferring or assuming a size of your facility and a certain amount of infrastructure, and it makes an estimate based on that. So I'll just enter something here just because it's required, but I'm not going to include infrastructure. You can then put more information about your site. You'll also want to select the state. You need to select the state. So I'll just select Alabama. And what this is going to do is if you select the NERC region that is the state default, it will automatically, based on the state that you enter, select the appropriate NERC region. If you don't want to, or for some reason you want to select a different region, you can select one of the regions. They're all listed here. Or you can select the industry average clinker or cement electricity grid. So the NERC region is again the electricity grid that you're looking at. So I'm just going to be looking at the state, or selecting the state default here. And your reference unit is either metric tons or short tons, depending on your preference. And you can enter some comments if you'd like. So then I'm going to save it. One thing to mention here is that whenever you're in the tool, you want to avoid using the back button on your browser, so there's this back arrow up here. If you do, it'll actually log you out of the tool. You'll want to always use the links right in the tool, so back to the EPD list, for instance. And so I'm just going to check, yep, my clinker was just made right here. Okay, I'm going to double click on it to open it up. And here we go. Okay. So we can move through now the different areas where you will be entering data directly. So there are these tabs on the top here, and each is, as I mentioned before, it's the same as the worksheets in the import template. And so you can go through these in any order, it doesn't matter. And there's also a couple of tabs for the results and exporting the data once you're ready to do that. So if we start with the materials tab, I would like to go through each of these fairly quickly just to give you some tips on first how you enter data, but then just some tricks and things to look for when you're working with the tool. So on each of the pages, you're going to see a few brief instructions at the very top that should help you a bit in kind of getting you started. You'll also see some values that'll populate here automatically. So materials, it shows you a mass balance, so you can kind of do a quick check of how much material or ingredients that you have entered below. So I haven't entered anything, so it says 0 pounds. In manufacturing, it'll also, instead will provide an electricity total and also a fuel balance. So you can get a sense for have you entered data appropriately, or is there something maybe funky in the information that you have? Okay. So in terms of entering information, on the materials tab, what this is essentially is your ingredients. And the first thing that you're going to see is a row called specific clinker, and then right below it is this default clinker. And the difference between this is that the specific clinker allows you to add a clinker that you've already created. So it'll list from your library all the clinker EPDs that you've created, so you can select one. Or you can go to default clinker, and you will only have one option, and it will be the default US clinker that's already pre-populated in the tool. So I might just select that, and then you can enter however many pounds or use a different unit of clinker that might be in your product. And again, you're entering information based on the reference unit. So because I picked short tons, my reference unit is going to be a short ton of clinker. So 100 wouldn't make sense here. I'd want to put 1 short ton of clinker per short ton of clinker. So this will, this kind of seems funny. You wouldn't necessarily need to do this because you're creating a clinker worksheet, or excuse me, a clinker EPD, but it's there if you wanted to. When you get to the concrete, or excuse me, the cement input section of the tool, it'll also have these 2 lines, and so that's when it becomes more interesting, which clinker that you're including. It becomes more useful here. So, but just a note on what the specific versus default clinker means. The other thing I wanted to point out here is water. So, so there are all these different types of raw materials that you can enter, and you simply just click on Add Exchange, and it provides you with all the options that you can enter. When you get to water, I wanted to kind of be clear on the different language here. There are 3 options here. Water itself just refers to tap water, so what you're getting from your public utility. Recycled water is what's being recycled within your facility itself. And then water unspecified natural origin refers to water you're getting from an on-site source, like a river or retention pond, something like that. So when you probably have seen this as I entered the default clinker, there will be a quantity that pops up, the unit that pops up, and then also the transportation will pop up. So by default, it'll it'll add a truck mode, but you can delete that if you want and add a different transport. There are options for rail and ship, etc. And then the distance, and again, unit. So it's pretty straightforward. But for every item that you enter, you want to enter the transport distance, and this is transport from the source to your site. So I'm going to go back to the EPD list and open up the default clinker from here, so you can kind of see how this works if there's already a lot of data populated. So I get navigated to my description page. There's my materials page right here, so you can start to see what it looks like as you're building your EPD. There's a lot of information that that you might enter. Sometimes it can be helpful to start with the default clinker, cement, or concrete, just so that you don't have to select all of these raw materials if you're pretty sure that they're probably the same or about the same, and then you can just change the numbers here. But it depends. It's just a preference. You want to start with the default and change numbers, you can do that, or you can start with a new empty clinker, cement, or concrete. Moving over to the manufacturing tab or page, just a couple of tips here. Getting to the electricity question that we had earlier, there are 2 sections for electricity use under manufacturing. One is electricity purchased from the grid, and just below is electricity produced on-site. And so the on-site really has to do with anything that you're generating on-site. If you have a turbine, a wind turbine, if you have solar panels, for instance, you can add those down here if that's applicable. I'm guessing in most cases, everyone is using electricity from the grid, so the top is going to be more relevant to you. And so when you enter when you select your NERC region, or you select your state, depending on which NERC region gets selected, what you'll see here is the data set that you've selected. So so in this case, I'm using the industry average clinker, so it's using the industry average clinker electricity grid mix. If I had picked a specific state or region, it would say that region, like SERC or ACC, for instance. So that's how you know what grid you're using. You would then just enter the quantity of of electricity that you're using, again, per reference unit, so per short ton of clinker, and you've got the kilowatt hours as your unit option here. And then these default values will be used automatically based on the electricity grid that you have selected. If you wanted to change these, you can. You would simply select this Use Custom Values, and you just click in here and change this to whatever number you want. And you can, and the tool will still show the default values here, but it will be using your custom values. All right, let's move on to waste management. Oh, actually, I wanted to point out one more thing under manufacturing, especially for clinker. So this isn't applicable to the cement or the concrete pages, but for clinker, it's actually very important. There's some sections down here related to the kiln. So there's one for kiln fuel. This should be fairly straightforward. And then if you scroll down some more, we're getting to kiln emissions. And so there are a couple of, well, I should say 3 sections of emissions. You have process emissions, fuel emissions, and emissions to air, other emissions to air. And I wanted to just spend a minute to better describe what these are. So the process emissions are referring just to calcination emissions. So be sure that you're entering just the calcination emissions when you get to this point. You may need to take your total emissions and subtract from that your fuel emissions, fuel combustion emissions, to get the calcination emissions. But if you need help with that, there's a bit of information in the user manual, and again, contact Dave if you have some questions that might be applicable to all users, and that could be covered under the support that we're providing PCA. And then under fuel emissions, these are the emissions just, I guess just the CO2 emissions really related to burning fuel. So what's released when you burn fuel to operate the kiln. My guess is that most of you are going to be using the EPA's greenhouse gas reporting rule method for calculating this, to calculate this value. But if you have measurements that's actually preferred, just be sure to include both biogenic and fossil CO2. And then if you have any other air emissions that you would like to add or that you have data for, you would add those down here. So anything that are not CO2. Okay. All right, so now let's go on to waste management. This page I think is pretty straightforward. It functions like the other pages with the different sections and the ability to add exchanges as you need them. One note here is that wastewater is categorized under this non-hazardous waste section. And if you're familiar with the PCRs or the EPDs that were developed, there is a non-hazardous waste metric that's reported, but the non-hazardous waste is only solid waste. So when you see the results, it will not include wastewater, and that's intentional. So in case you're wondering about that or something looks funny, wastewater is characterized as non-hazardous waste here, but it's not counted as a non-hazardous waste in the results of the LCA. Great. Let's go on to the next tab, which is products. So this is a list of everything that's coming out of your facility as a co-product. You don't have to. There's no entry of the clinker or the cement or the concrete as a product that's inherent in the tool. It's everything else. So if you're generating electricity that maybe is going back to the grid, if you're generating CKD and you're either using that on your site or selling it off-site, you would want to enter all of those things here. So this is where you would track that information. Okay, so think we can move on now to the results and what those start looking like. There are two ways to, I guess, look at the results. First, you have this global analysis worksheet, and then you also have the LCA analysis worksheet. So in the global analysis, this worksheet is going to show all of the indicators that you need to report in your EPD. Remember that the results here are per reference unit, so per short ton of clinker. And the results are divided between A1 to A3 and A4 because A4 is optional in the cement PCR, so you don't have to report that, so that's separated out. A note on net fresh water, which I actually used as an example earlier in the webinar. This includes water from cradle to gate. So it's not just the water that's being used at your site. It includes everything upstream. And electricity generation, especially if you're using electricity from a coal-fired power plant, it requires a significant amount of cooling water. So if your net fresh water looks way bigger than what you were expecting, it's probably because of that water used during electricity generation. So just note that that's a cradle to gate number, not just a site-only number. We do have a site only number in the EPDs that were developed for cement, industry average cement. So that's something to note if you're thinking about what's on those EPDs and not clear how that differs from what's here. One other thing to note is that clinker is going to be the largest contributor to impact. So the more clinker that you have in your product, the higher the results values are going to be, and it'll have a significant effect on them. So that's another way you can kind of check your work, is if you have a number of EPDs, a quick check would just be to look at the clinker content, and the products with more clinker should have a generally higher impact in all of these categories. Okay, so the LCA analysis is another way to look at the results, and this is organized a bit differently, and the purpose of this page is for you to be able to kind of drill down to see where different impact is coming from. So it's set up a little bit differently than the global analysis table. On the top you have the environmental impact, and you can select up here whether you want to display just the indicators that the PCR requires, or if you want to add some toxicity indicators that the tool also calculates as additional information. But these toxicity indicators are not required by the PCRs. So you have the option to add those if you want. I won't select that right now. But so you've got the indicators noted up here, and then on the left side what you have are, it's kind of a hierarchy of the different processes and activities within your cradle-to-gate production process. And so you can start to drill down into where things are coming from. So using these arrows, you can open and close things quite quickly. So if I close everything except that second level, I can just compare my materials, manufacturing, transport, and waste management. And you can see that these align pretty well with the worksheets or the tabs on the top here. Transport has been pulled out as its own kind of category. But you can start to kind of drill down in each indicator to see which, I guess, where the impacts are coming from. So for instance, for global warming potential, the majority of impact is coming from manufacturing, and I can drill down there and see, okay, there's a lot coming from electricity, purchased from the grid, and there's also some coming from my emissions to air, and then you can drill down again and see exactly what kinds of emissions or what kinds of activities are contributing to emissions to air. So it allows you an additional level of resolution, so you can kind of pinpoint why, I guess, where sources of impact or where the impacts are coming from. But also if you feel like maybe the results are a bit too low or too high, you can drill down and see why that might be, and then go back to your worksheets and check the data. One check you can do in terms of looking at impact, a lot of the impact that you should see should be coming from manufacturing, or most of the impact. A lot comes from materials as well, but the majority is coming from manufacturing, and depending on the indicator, it's either going to come from emissions to air or from electricity. And so you can kind of use that as a check of when you look at your results, is that where my impacts are coming from, or is it something else kind of making it look a little wonky or something off? So just check the emissions to air and your electricity, and those should be main contributors to impact on your manufacturing stage, and manufacturing should be the main contributor to impact. And that's the case for clinker, cement, and concrete. Okay. One more tab I want to go through, so the export area. So this is where you can export the results of your EPD in a number of different ways. You can export the background report, which gives you it looks a lot like the import template that I showed earlier, except that it'll have all of the inputs populated and with the data that you entered, as well as a worksheet of all your results, and those results will look like what you see in this LCA analysis tab. So it's kind of a spreadsheet version of the LCA analysis. You can also export the self-declaration, and what that is a worksheet that just provides the results of the LCA metrics. And let me see if I can pull that up here quickly. There we go. So it'll look like this. It's just a one-page document that has the results of the LCA that you've done, very similar to the global analysis worksheet. Okay, and a little bit of information about the product that you're analyzing. Okay. All right, so maybe I'll stop there. The next section I want to move to is talking about developing an EPD and the process for that. Who are the players and what roles does everyone play? So before I get into that, let me take any questions on the tool or on the LCA and EPD content that we presented earlier, if there are any questions about that. So Dave, have any questions? Yeah.
There are a couple of questions. I want to have you, well, the question came in, I'll just read it off and maybe you can, you know where to pull it up. Actually, it was a comment. Emissions should be quantified in tons except dioxin, which are in grams. And I'm assuming that is essentially the comments generated because you're working out of in this particular example, a short ton of clinker. Is it I'll let you pull that up and see if that unit changes or how to explain that.
Yeah, so the units, if you're working directly in the tool, you can change the units. So you have the option to select tons, kilograms, short tons, pounds for if you're entering, I guess, process emissions. And for other emissions, this custom list, there are smaller levels of units. So you're right that the unit, the scale of the unit is different based on the emission. So that does come into play here in the tool.
Great. The next question was, could you repeat your wastewater descriptions again?
Wastewater description, sure. So I think you're talking about wastewater here, but I'll go over to the water definition as well. So wastewater, so water coming out of your facility, is characterized as non-hazardous waste here in the tool, just because it needed a place to put it, but it's not counted as non-hazardous waste in our global analysis. There's the indicator at the bottom. There's an indicator for hazard or non-hazardous waste generated, and this refers just to solid waste. So there's only 5 kilograms, whereas wastewater here, 113 gallons would certainly be more than 5 kilograms. So, so that's what I mean when wastewater is categorized as non-hazardous waste, but not included in the non-hazardous waste metric in the results. If you're referring to the water under materials, there are 3 different options for water here. There we go, at exchange water. So there is water, which is tap water, something that you're getting from the public utility. There's recycled water, so that's water that you're recirculating throughout your facility. And then the unspecified natural origin, this is just water that is coming from your site or an adjacent site that you're directly taking from a resource, a source of water. So you're taking from, got a pipe you're taking from the river, you're taking from a pond or a lake, or even a retention pond on site. Does that make sense? Did that answer the question?
It does to me. Excuse me.
Okay.
It does to me, but I'm not. I'll ask if the original person posting the question has more questions. We can talk about it offline. The next question that comes into play, it says, for concrete producers who may want to run hundreds of mix designs through the tool, do you have a recommendation for efficiently running a large number of these?
What was the last part of whether they should be running a large number or how to?
Is there an efficient any methodology to say run variations on a from a typical plant?
Yeah,
where you have a producer that. Go ahead.
That's a great question. Yeah, so I would say to start with the with creating one product, whether they do that through the tool or through the import template, either way, and then you can just keep creating copies of that. If you have hundreds, I imagine you don't want to be sitting here duplicating 100 of your EPDs. So in that case, it could be something where our IT team at Quantis can help you generate those much faster. So I would say you can get in touch with us. Arno, I don't know if you have any other anything to add from kind of the IT perspective in terms of generating 100 or so EPDs at once or in a streamlined manner.
Yeah, well, I think you got it right. I mean, given the functionalities of the tool, the best option is, as you said, start creating one, export the background report, and then work in your spreadsheet software to create all the variations of the base concrete. And then, as you said, you would need to import all of these, which would populate the 100 different types of concrete in the tool. So that is probably quite a tedious work, even though you can optimize a little bit using Excel for the variations. And if this is an issue because there are really a large number of concrete EPDs to import, then I think the best way would be to contact us to see how we can optimize that outside of the tool.
Very good. Thank you. The next question, and this is a great question from my perspective. So it says, when submitting an EPD for verification, is the background report the LCA report? So you showed us, Amanda, the two self-declarations and the LCA report. And I'm assuming that that LCA option, when you were producing it, is what would be handed over to a verifier to verify for an EPD.
Yeah, so this is a good question, and it will depend on which program operator you use. If you're not familiar with this terminology, I'll get into it in just a few minutes here. But if you go through ASTM, because they were the ones to pre-verify the tool, they will. There's a good chance that the verifier may not ask for this background report, may not need it. If you go through another program operator, they may be more interested to see it. So that's what these. And actually, let me go to the tool so you can see that. I think that's probably more useful. But yes, this is the LCA core model and database report. That's the LCA report. And then the project database, they may or may not be interested to look at, they being the verifier. That is the background data that kind of accompanies this report. But those are the two key documents. If you're not working with ASTM, they may also want to look at the verification report just to ascertain that the tool has been pre-verified, and that's right here as the last bullet on this landing page.
Okay. My next question here is, should I fill in both manufacturing and materials water, or either one or the other? So I'm and this very well may be from a ready-mix producer, where their water applications in ready-mix production are different than cement and clinker.
Okay. So it's a good question. So in terms of the materials, I guess maybe Arnaud, I'll leave this to you. You might be more familiar with the concrete part of the tool.
Sure. Well, if I'm not mistaken, this is going to be the same situation in all types of products, meaning clinker, cement, or concrete. But you will see that you have the possibility to type in the water use and water input in both materials and manufacturing. So typically for the manufacturing of concrete, you would type in the water used as material in the material section, and you would type in the water used for manufacturing purposes under the manufacturing section. So typically you differentiate among the different uses of water. Nevertheless, that would not have an effect on the results.
So as I would understand this, for example, if I'm a ready-mix producer, and I'm getting data from a cement supplier, they're going to have water quantities attributed with that cement production, and that can either be the default that comes through in the information, or you can modify it appropriately. But then you would add your own water use for the actual concrete production as well.
Exactly. You would have to type in only that one, actually. And
okay.
Whatever comes upstream from the clinker manufacturing would already be included in the clinker process.
Great.
And cement, respectively, same thing.
This is a tough question, and I don't think that this, well, I think I know the answer, but I'm going to ask the pros. So when a product is being defined in Lead V4, it refers to it being used for a particular purpose, whether it be a sidewalk or a beam or whatever. Can the products be defined in that manner, such as grout or slurry, etc.? So this might be applicable, say, from a like a masonry contractor will be filling concrete block walls with grout to add strength and reinforcing. Do you guys have an input on that? And if not, I'll see if I can help try to answer it.
Yeah, I'm not sure I completely understand the question. I would say that the cement and, well, clinker too, cement and concrete, the tool itself are fairly generic in terms of kind of the setup of material and energy inputs and outputs and things like that. So as long as what you are using in your processes are available in the tool, then you can, generally use the tool to represent your product. But I guess I would, it might not be that straightforward, so I might caution the user in that, and maybe suggest that they talk with us on the side about whether it's, I guess, how to do that appropriately. Arno, do you have anything to add?
No, actually not really. Maybe what I can say is that there's nothing in the tool that is specific about how any product is being used. The system boundaries for the product characterization is at the, well, planned gate if you're considering only A1 to A3, or at where the product is being distributed if you're including also A4. But the use of the product itself is not considered in the tool.
I'm going to, as I've sat here and listened to both of you and thought about this as well, I'm going to jump back in and see if I can help answer this. So in LEAD v4, they require multiple products that submit EPDs to get the credit. And it's my understanding in my work with our NRMCA colleagues that multiple mix designs can be applicable or can be considered multiple products on a job site for LEAD v4 credit. In other words, a mix design that incorporates air entrainment and is appropriate for sidewalks and plazas, etc., out on the site work is going to be a different product than, say, beams and columns, where you may have a higher ultimate strength and different other different plastic properties to the cement. So I think to this question, products such as grout and slurry could potentially be considered a specific product. They're going to have different mixed design aspects, different plastic properties, etc. So I think in that sense it is appropriate. And I've gotten a confirmation from one of my colleagues at NRMCA on that as we speak. That ends the current list of questions that I'm got up here on my screen. So I will let you move forward.
Okay, great. Well, why don't we move on to the next section then, which is talking a bit about the process to develop a product-specific EPD. Bring this back up here. Okay. All right, so I think the big question, and the first question to address is why would you want to be developing a product-specific EPD when these average industry EPDs for cement and concrete are available? And simply it's because your product may actually have a lower impact than the industry average product. And if you're a cement producer and that's the case, or then your ready-mix customer will probably want your data instead of the industry average data, because then their EPD results are going to have a smaller footprint. And similarly, a ready-mix producer with a lower footprint than industry average can then use that as a selling point with customers and other stakeholders. Or if you think you have a specialty product that might not be well represented by the industry average, then you may want to develop a product-specific EPD. So if you decide to go ahead and do that, there is kind of what I've kind of put together here is a 5-step process. This isn't kind of an ASO-specific process or anything like that. It's just kind of my summary of the process, overall how things kind of flow. But what you'll see here is kind of these 5 rectangles that indicate a general step of the process, and then these circles are identifying who the players are during each step of that process. So the producer being a provider of clinker, cement, or concrete, well, I guess I should say cement or concrete, the program operator, and then the verifier. So let's see here. So it's, like I said, there are 5 steps in general to producing an EPD, and let's step through each of these. So when you're first thinking about publishing an EPD, you need to decide which program operator you want to work with. And if you're not familiar with this language, a program operator is an entity that essentially houses EPDs and also supports an EPD developer, product provider, through the development process. They can recommend verifiers. They'll be the entity to then register and publish your EPD to their website. If a PCR hasn't been developed from for your product category, then you'll also work with the program operator to do this, to develop a PCR, which doesn't apply in this case. But and so you probably are already familiar with groups that are program operators, and you might not realize that they are. So ASTM, NRMCA I mentioned before, but also folks like UL Environment and EnvironDeck, and many others across the globe actually are program operators. So once you've selected your program operator, then again, if there's a PCR that is not in existence, you have to develop one for your product category. Otherwise, you can generally select any PCR that's available, regardless of the program operator that houses it. So you may decide you want to work with ASTM, but you want to use an EnvironDeck PCR. You'll have to talk with your program operator, but usually that's okay. But again, let me just move through this section quickly, because it really doesn't apply here, because we've already got the PCR for cement and concrete written for the U.S. All right, so once you've got your PCR selected, then you go into the process of developing the content for your EPD. This includes both doing the LCA, or using the tool to do the LCA, but also gathering all the other information that's required by the PCR. So the descriptions of your products and the manufacturing process, if you're going to put together an introduction, if you want to, I guess there's also a lot of standards or specifications that you might need to list. Any other additional environmental information that you want to include. There's a whole list in the PCR that are either required or suggested to include. And that's really all up to you. So it's really the producer that's developing the content, maybe with or without help from an external consultant, or just someone who's been through the process before. So once you have that all together, you'll start your verification process. And like I said before, the program operator can help you select an entity to do the verification. This does need to be somebody who was not involved in developing the content. So for instance, if you have enlisted Qantas to help you out with doing your LCA or helping you otherwise with your EPD, we wouldn't be able to verify the EPD for you. And verification is done just to assert that your EPD does indeed conform to the PCR. The process does require some back and forth between you or your LCA service provider and the reviewer. So you should plan for several weeks of kind of this iteration. If you use the tool, the verification is going to be very much streamlined, because there won't be a need to check the assumptions, the calculations, or the methodology of the LCA. This was all part of the tool verification process, so it actually reduces the time and the effort needed during verification. So during this process, it's really you as the product provider or producer working with the verifier. And again, you might have some support there to help you through that process from an external consultant. And then the next step is to register and publish. And this is really all done by the program operator. So once the verifier has provided you with a letter of attestation stating, yes, this EPD conforms to this specific PCR, you send all of that to your program operator. They do a review to assure everything that was done, the verification meets the requirements that they have, and they will then officially register and publish your EPD on their site. The process there is usually pretty fast, somewhere in the range of a couple of weeks, definitely less than a month in most cases. So this is something that can happen quite quickly if if you are able to get all the information to your program operator at one time. I do want to emphasize a couple of key points on these last 3 steps, because these are really the key steps in developing your PCR, or excuse me, your EPD. So first, on the content development, if you could stop here, and what you would produce essentially is an unverified EPD. And this is what we refer to as a self-declaration. And I say we, but it's also defined in the ISO standard. So you might create a self-declaration if you want to maybe just get a feel for the process of data collection and entry, or if you want to compare your product results to the industry average results. So this can be useful, in those 2 contexts. It's really a quick and dirty evaluation because, again, there's no verification process at this point. You can also use this information in LEAD V4. It does count towards a quarter of a product, but you would get more points if you provided with your product either an industry average EPD or even better, a product-specific EPD. But LEAD does count self-declaration as more than 0. About verification. So there are some, well, I should say verification and registration. There are costs related to verifying and registering, and these are set by the program operators as well as the verifiers. Based on our experience, verification is typically in the range of about $5,000 per EPD. That can sometimes be streamlined if you have a lot of EPDs and there's kind of a scale of economy to it. Again, you would work with the verifier and maybe the program operator to define those fees. The registration process is set, the fees associated with that process are set by the program operator, although some don't have any fees. So for instance, ASTM does not charge to register or publish your EPD through their program. Others that do charge a fee are, again, typically similar to verification. It's about $5,000 to register, and then if they have an annual fee, some do, it's typically $5,000 a year. And I don't mean to say that if they're going to have fees, they will have a registration fee and an annual fee. It could be one or the other. It could be a package that includes a verification fee that is applicable if you use one of their verifiers. So there's all different ways that program operators package their fees. So I just wanted to give you an initial sense for kind of where costs might be incurred and how much they might be. But you really need to talk with your program operator and the verifier to identify exactly what these fees will be and how that cost structure works. Well, that takes us to the end of the presentation part, and we're right on schedule, but a bit early even to start taking questions. So thank you everybody for your time and for speaking with us through an hour and a half. Dave, I'll turn it over to you and we can start answering questions that everybody has.
Let me take myself off mute. I have no additional questions from the battery of ones that I provided to you earlier. Could you go back one slide, however? There we go. From a PCA perspective, just to give you some context, we developed our 3 EPDs, 3 specific cement EPDs, during the course of 2015 with ASTM. And as Amanda mentioned, there are multiple program operators out there, UL Environment, SCS, NRMCA, ASTM, and others. In most cases, I think what you'll find is that just opening up the discussion with them, you can get a lot of this information pre-negotiated once you have an understanding of their product or the type of products that you're trying to assemble and to publish. One of the questions I have for Amanda is on time. I understand that your EPD is good for a 5-year period, at which point you need to well, maybe not. You have to re-up it. You have to go through the process again. And I'm assuming that recertification is quicker, a lot less painful, and probably less expensive. But I don't know that. Can you speak to that?
Yeah, again, it will. It's based on 2 things. One, again, the program operator, what their requirements are, but then also how much has changed over time. If you're creating a new EPD that's very different, or I guess the content is very different, if you're just redesigning it and the numbers have barely changed, you know, there's probably not as rigorous of a process that needs to be applied. But if you're talking about, you know, we changed some really key numbers or some other key information that's been modified, they may want to go into a more robust review process again. So it really depends on how much the information has changed and what the program operator's requirements are.
All right, I have gotten a few more questions since we started this. One of the questions was, will a PDF of the presentation be available for distribution? And the answer is yes. We'll be working with our web developer here at PCA to provide a link, and I'm not sure where that link will actually reside, but we will provide a link to the recorded presentation that you've just seen here. Along with that link, we will take both the questions that were sent in and kind of capture some of these questions and put them in a Q&A format just as a Word document, so that you'll have that to pick up on. Next question I have is, who would we contact if we would like to verify that we have used the tool correctly, e.g. PCA industry sampled plant? I'm not exactly, well, the way I understand that question is if you're going to use the tool just to give it a try and see how it works out, and you want to take a printout of your report and see if it passes the laugh test. Frankly, I think that's a very good idea, given the fact that a lot of this information is maybe different than what we're used to handling, at least in the context of the environmental impacts. And so you could certainly contact Qantas as a consultant. There are other players out there that would be able to provide LCA insight into this. If you've never done it before and you're looking to do a self-declaration, you can run the numbers and compare it to an industry average and see how that works. And you know, if you just have a half a dozen questions, it might be something as simple as contacting somebody like Qantas, who knows the program inside and out, and seeing if you can run a few questions by them. If you're talking about something of significant more time and effort, then maybe it's a matter of just simply hiring an LCA consultant to get you through that process. I personally would, having now gone through this and the learning curve, I would strongly recommend that you bring in a consultant on at least the first pass so that you better understand what, not only the information that's coming out of it, but making sure that you're putting the right information into it and understanding the interpretation as well. How will the next question?
Dave, if I may, maybe I could add a little about this. There's one thing which I would like to well, emphasize, is that this pre-verification of the tool, which Amanda mentioned earlier, also means that the verification process is expected to be simpler than if you would go, I mean, when publishing an EPD that was created from the tool, then if you would go and prepare and publish, register your EPD from scratch without using the tool. And the main reason for that is, well, because the pre-verification that was conducted, so by a third-party verifier, was meant to ensure that the LCA model that's been implemented in the tool is compliant with the two reference PCRs for cement and concrete in the US. And as long as you're going for the EPD program operators where the two PCRs are registered, in principle, you will not need to go through the verification of the LCA model again, meaning that the scope of the verification will mostly relate to the input data, and the verifier would want to check that whatever input data was used in the tool does correspond to the real situation. So they might want to to check or to have a proof that the electricity input you used corresponds to the reality of your operations. But that doesn't really need any LCA experience for that.
Okay. Then to Arno's point, if you were to go through an EPD process on your own without this tool, one of the steps would be that the verifier would not only look at the data that you've input, but also the assessment conversions that are applied by the LCA consultant that would be helping you. And that those environmental impact assessment conversions have been looked at. In this particular case, the verification was done by the Athena Sustainable Materials Institute. The tool was also pre-verified for the European or international version by another LCA consultant over in Italy. So it's kind of been through the process twice. But to Arno's point, that double check on the conversion, the environmental impact assessment, has been done, and it's really part of the intent of the whole development of the tool, which is to save multiple reiterations of that same process being done for cement and concrete producers. So if you've produced your own EPD and you do 1,000 more, your consultant would start to understand that and not have to double check the data. In this case, this is what we've done in the tool so that that data does not have to be double checked. The first time a verifier may look at this that hasn't not seen it before, they may have some questions. However, I don't want to make a blanket statement, but the intent is the pre-verification was to resolve that, take that part of the workload out of the equation. The next question we have is, how will the tool be maintained as background data is updated and improved? PCA has a maintenance agreement with Qantas, as well as the CSI has a maintenance agreement with Qantas to continue to update information. And so we have it as part of our annual budget to work with Qantas for, say, energy profile updates, and the issues that may change. For example, if the background PCR for cement or concrete changes, then the tool needs to obviously be updated. So they all kind of go hand in hand. The next question is, how long does it usually take to complete an EPD on a concrete product? I will admit I cannot answer that question because we've done it on cement. So I'll ask Arnaud or Amanda if they have any experience or exposure to that on a concrete product.
I could speak to it in general, but not on the, I guess I haven't had a concrete EPD that I've personally worked on. Arnaud, are you more experienced in that realm?
Well, let me try and clarify this a little bit. The process of going through an industry average EPD as opposed to a company-specific EPD is totally different. Meaning that it's a lot more complex to prepare an industry average EPD. As you can understand, I mean, you need to have some representativity of the samples and to cover a certain share of the market, and doing weighted average inventories of a given industry average product is a complex process. Now, if you're aiming at producing a company-specific product, and especially a concrete one, you will realize that, well, the process of typing in and collecting the information that you will need to prepare your concrete EPD is relatively straightforward. I mean, obviously you need to be aware of what materials you're using in your manufacturing process, where the different materials are sourced from, and by what means. And then the manufacturing process itself for concrete is relatively simple compared to what you can get for clinker, for instance. And,
so you had mentioned earlier that it's a couple of weeks for a verifier to do their work. Is that still
yes,
applicable for the concrete one as well?
Absolutely. Yeah, it goes like this, although I would say that it will never take as long as one for cement or for cement, but you might have predefined time slots of the order of a couple of weeks indeed that a verifier will require to go through the verification. And I guess as you mentioned before, it will probably be quite different depending whether it's the first round, or
sure,
the next ones. And
go ahead.
What I wanted to say is it will take you, let's put it that way, each concrete manufacturer can have a good estimate of how much time they believe they will need to collect all the data that's needed for the EPD, for the inventory, meaning materials, manufacturing process, and waste management. And depending on how structured, how organized the company is, it will take more or less time. Yeah. One key aspect of producing a concrete EPD would be, and here I'm thinking of a non-vertically integrated, would be to what extent you're aiming at obtaining the environmental performance of the specific cement you're using, meaning from the actual cement from your supplier or suppliers, or if you are aiming and using the industry average cement EPD as a cement input. And that might have an effect on how long it will take you to prepare an EPD. But if you're aiming at using the industry average cement, concrete manufacturers should be aware that this is already available as such in the tool, so they can just decide to use the industry average Portland cement, for example, and have that already available. And at the opposite, if they want to try and obtain the data or the results from their specific cement supplier, that might make the process a bit longer, depending on whether the supplier in question has EPDs or not.
Sure. Okay. And to the person that asked the question, and this is honestly, this is probably as applicable as anything. It probably has a lot to do with your program operator as well. So the first question that I would pose, or the first step I would propose, and it's really what Amanda was talking about, is contact the program operator, and you may want to contact 2 or 3 of them to get various input, including what their fees are, their scheduling. They may be either very busy or they may be very slow, and so sometimes it's just simply a matter of getting scheduled with available verifiers. I know that at ASTM, which we went through, they had 3 or 4 different consultants that were available for verification at any one time, and they would spread the work around. So your program operator is going to have their own internal calendar of events on going through this process as well. Another question that came up is, if other program operators are interested in verifying the tool, what would be the process?
Good question. I would say that we should sit down with each program operator and talk about that. I think that that's certainly an option, and I think maybe favorable for the industry, or an interest by the industry to do that, but I'm not speaking on behalf of the industry. I just think it would be beneficial for multiple program operators to approve verified. So if you are a program operator asking this question or otherwise on the call and you're interested in that, please do get in touch with me or with Arno, and we can start that conversation.
Maybe I can add one more comment here. This is a very good question indeed, because there's I would say a little trick in the answer we can provide. I mean, there are different situations. Yeah, the tool was developed based on 2 specific PCRs for cement and concrete, and these are the PCA's cement PCR that is registered at ASTM, and the concrete PCR that is registered at NRMCA. These are the 2 PCRs which the tool complies with, and publishing or having the tool verified by another or by a different EPD program operator leads to the question, what PCR would then be used by that specific EPD program operator, and what would be the possible extra requirements that this extra EPD program operator would need. Yeah, the tool has already been proved to comply with the 2 PCRs I mentioned before, and in case another or a different EPD program operator would want to verify the tool, then I would assume that if it refers to the same PCRs, then the process could be relatively quick. And if it happens that the reference PCR for either cement or concrete in that EPD program operator is different, then the process would be a totally different one, and might be a much longer process. But as long as the PCRs would be the same, then the process should be relatively straightforward.
Great, thank you. The next question comes from the ready-mix side, and I don't have an answer to this, and I'm positive that Arnaud and Amanda don't either. And the question is, have there been any cases where companies have been able to invoice a construction project up front for EPDs on the products to be used? And I have not heard of that. The discussions that have taken place in the green building world have considered that this is similar to like they call them safety data sheets, that it's a transparency report to convey your impacts of your products to your customer base. That said, if any folks are on the call that might be aware of such a thing, including my colleagues at NRMCA, that if you have information or evidence of something different, please let me know, and we will include it on the Q&A sheet that gets attached to this document as well. Let's see. Next is really more of a comment. NRMCA is a program operator with an existing infrastructure of LCA experts and EPD verifiers. It was designed specifically for concrete producers, so working with the NRMCA can expedite this process. So this is really addressing the earlier question of how long does it take. I know that they've got multiple EPDs that they've already produced, and NRMCA's got, again, a handful of verifiers and LCA folks that they've been working with. So that is certainly an option. Whether they choose to use this tool or not is really their call, but that could be something that could certainly be looked at. With that, I have no other questions. If you have a question you'd like to post up here, please do it now. Otherwise, we'll wrap up this call, and thank both Amanda and Arnaud for sharing their time and expertise in exposing us to the complexities and the advantages of the EPD process and the use of the tool. I appreciate all of you folks that are on the call. I don't see any other questions, so with that, I will close this out. If you do have a question for offline, please let me know. You can contact me at dshepard@cement.org. If there is a program operator that's interested in contacting Qantas, you can contact either Amanda Arnaud or Arnaud to talk about pre-verification issues. Thank you again, everybody, for your time, and we'll be signing off now. Bye-bye.
Goodbye. Have a nice day.
Thanks, everyone. Goodbye.